Welcome. I'm Raghuraman Krishnamoorthi. I work at Facebook on the PyTorch team on quantization, and I'm here to talk to you about practical techniques that you can use to quantize your models. Here's an outline of the talk. We'll start with some motivation, introduce quantization, and then dive into practical details on how do you integrate it into your overall workflow and summarize with some best practices. So why do you want to do quantization? This is a slide that requires no explaining to the audience here. There is an explosive growth in the number of devices that require AI capabilities which are getting deployed. And these devices are going to be resource constrained, many constraints in terms of compute, memory bandwidth, power, connectivity. At the same time, there is an increase, and there's an exponential increase in the accuracy in the trade-off between the accuracy that you can get and the complexity that it takes. And this is true for vision. Here's an example sort of showing what happens if you want to go from, say, 75% accuracy to 80% accuracy. You literally have to increase your complexity a factor of 10. And this is true for other domains. For example, if you take natural language processing, the same trend has repeated in the case of transformers. You had BERT, which was followed by GPT, which was followed by GPT-2, which is followed by the huge GPT-3 models. And if you're interested in power, this increase in model size is a bad sign, because increased model size means more memory accesses. These models are wider, they're deeper, and increased memory access is the number one thing that sort of affects your power. And in fact, it's a nonlinear effect in the sense that if your model is small enough to fit in your cache, then you're usually okay. But the moment your weights or activations for a layer don't fit in the cache, you sort of have a cache miss. You have to access higher layers in the memory hierarchy, and there's a steep penalty to pay for that.